Hello students, here we are discussing relation between wave velocity and particle velocity. Wave velocity V is equals to n lambda, V is equals to omega by k. We know this. So when you're talking about particle velocity, particle displacement, so that's y is equals to a sine omega t minus kx. So this we discussed in the previous session. So it's the particle velocity Vp is equals to dy by dt. This is on proper differentiation. So a omega cos omega t minus kx. Okay, it's what Vp. So particle velocity. Now I'm talking about what is the slope of the equation. Slope means what? Dy by dx. So for the dy by dx, slope is minus. So first one, just I'm writing about first d by dx times of y is, we have from this y, what is here? This is the y. Y is a sine omega t minus kx. Okay, so this is slope dy by dx is equals to, so minus a k, okay, cos omega t minus kx. Okay, so this is particle velocity is the first one, and the slope is what? It's a second. Next one, from these two equations, equation 1 and 2, from the equation 1 and 2, 1 is divided by 2. So 1 is what? Vp. Vp is equals to a omega cos omega t minus kx by, so this is dy by dx, it's a slope, okay, is equals to, so this is minus a k cos omega t minus kx. Okay, so these two will be cancelled, a and a cancelled. So here we can say Vp is equals to minus, okay, minus omega by k into dy by dx. You know this is what? Wave velocity. Particle velocity Vp is equals to negative slope. This is slope of wave velocity is the relation. Differential equation of wave motion. The differential equation is d square y by dx square is equals to 1 by v square d square y by dt square is the differential form of wave equation. Y is equals to, if I write a sine omega t, y is equals to a sine omega t means next one I'm writing as a kx. Okay, so these do not actually satisfy so the wave equation. So these are particle displacements. This we can say particle displacements. So particle displacements. So what do you say now? Do not satisfy the wave equation is the wave equation. So how should it should be satisfied, the wave equation? So wave equation, it must be as a function of x, t, and next one is the position. Okay, so wave equation, when you're writing about the wave equation, so it should satisfy, means the function to be with the three quantities. Okay, so a wave equation must contain what? It's what? Three quantities. Three quantities are, one is x is the position, v is the velocity, and t is the time taken. So it must be appeared like x minus vt, yes, or x plus vt. It must be represented by in the form of like. So we can also write x minus vt whole square. Okay, but sometimes it appears for in a questions which of the following is general equation for the wave propagation. Okay, so for example, if I say x square minus v square t square is not satisfy, okay, not satisfy the wave equation. So this is it not satisfy the wave equation. It is not possible. So only the wave equation is what? This, it should be in the form of like this. If you have, there is a minus negative sign. So it's along with positive x direction. Okay. So positive x direction. This is what? If it is plus negative x direction. Okay, negative means positive x direction means what? Wave should be propagated in the forward direction. Negative x direction means what? Wave should be propagated in the backward direction. Okay, so like we can write it as this is if I write as a any some question, if you choose based on this. So for example, y is equals to as a, so some this is what the equation of displacement of the particle. Okay, so particle is mentioned, but when I write in terms of this x minus vt means as a function of x, v and t is there, this is what? Wave propagation. So we can say as this is what is the velocity of wave. Velocity of wave is v. So v is what is it? This is the velocity of wave. Velocity of wave. So what direction? Negative. Negative means what? Along with positive x direction. Along with the positive x direction. So like we can write on a snapshot. We can say this is what? It's a snapshot. Snapshot. A photo is taken at that interval, so it appeared like this picture. Okay, so then from this first question is which points have upward velocity, which points have downward velocity, which points have zero velocity, and next one, which points have maximum magnitude of velocity. So for this is for the fourth one, first I'm giving the answer. Fourth one is which points have maximum magnitude of velocity. Is a transverse wave. Okay, the wave is propagating. Propagating means what? Particle is moving. So its direction is what? Towards here. Its direction is what? Towards here. It makes the oscillation. Okay, when a particle, for the fourth one, when a particle executes, okay, it's what? Executes SHM, simple harmonic motion. Okay, it has, the particle has, okay, maximum velocity at mean position. Okay, at mean position. So mean position means what is your answer? This is this one, this one. Okay, so for the D question, okay, here we can say B, next E and I. A, E and I. Okay, fourth one is completed. Next one for the first, this is first one I'm talking on this. Which points have upward velocity? So for this, what concept we need to follow? The concept is what? V, particle velocity, Vp is equals to minus negative. It's a slope of wave velocity. Okay. First you need to find about where the particle has so negative slope and a positive slope. First one, here you can say this is less than, so with x-axis. Okay, first to find the slope at any point in a sinusoidal wave, first you draw the tangent, draw x-axis, draw the tangent, draw x-axis, draw the tangent, draw the x-axis, like this. For everything we can mention tangent is drawn and x-axis. It's a tangent x-axis. It's a tangent x-axis. Okay, so it's tangent x-axis, like this. So what is the angle? This is theta. Here theta. Okay, here theta is less than 90. Theta is less than 90. What type of slope is this? Positive slope. Okay, so this one also positive slope. This one is what? 0. Okay, here is what? 0. So here you can say as negative slope. Negative slope. So this is 0. Next one is here also more than 90. Negative slope. Here negative slope. Here 0. So this is again positive slope. So this is what? Positive slope. Now, if you want to know about particle velocity, it should be negative wave velocity, okay, minus negative slope of wave velocity. If it has negative slope, particle has positive. So negative slope, particle has positive means what? Positive means what you say? Upward direction. Negative means what? Downward direction. Which points have upward velocity? Okay, which points? So these have, which points I have the D. So first question is what? It's a D, this. Okay, negative slopes, where are these? Those we need to find. D, E and F. Okay, for second one, downward velocity. Downward velocity means what? Minus. Minus means what? Slope should be what you said, say, according to this one, positive. So which one have positive? So A, okay, this, okay, A, B, and next H, okay, next one is I. Okay, so for the third one is 0. You know this is what? It's a which points have 0 velocity. 0 velocity means what? Slope should be 0. So where slope is 0? At C and at G. So C and what? It's a G.